Hello folks, we come to the part 7 video of the miscellaneous exercise of chapter 9 and we are going to take the 19th problem. The problem says that between two numbers a and b, the arithmetic mean and geometric mean, they have a ratio m is to n. If that is given to us, we have got to show that a is to b keeps up this ratio. So let's, it's like just putting up of definition and getting the thing. So according to what is given, let's see. The ratio of the arithmetic mean and geometric mean. Between a and b, we know the arithmetic mean is a plus b by 2. And between a and b, we know the geometric mean is root ab is equal to m by n. That is what they have told us in a nutshell. We will use this, and part of it we have done in an earlier problem in the geometric progression. So it wouldn't be much tough to get across. It's as good as writing 2 root ab equal to m plus m by n. We will use componendo and dividendo and see how this comes by componendo and dividendo. Numerator plus denominator, numerator minus denominator. So numerator plus denominator, numerator minus denominator. This we had seen, as I said in the earlier problem, that this is as good as writing root a plus root b the whole squared by root a minus root b the whole squared is m plus n by m minus n. For our convenience, in order to get this apart like that, let's take roots on both sides. So when we take square roots on both sides, this becomes root a plus root b, root a minus root b, and because there is no square root here, we will have square root of m plus n by square root of m minus n. Because there was a square here, we are left with this. Our idea is to get a and b, we know. So somehow we have to have this root removed. So we'll do one thing, we'll apply componendo dividendo once again. So again, by, I would like to call it C and D, componendo and dividendo. What will happen? Root a plus root b, numerator plus denominator, numerator minus denominator. Numerator plus denominator, numerator minus denominator. So what happens here? b cut, root b, root a cut, 2 root a by 2 root b is root m plus n plus root m minus n by root m plus n minus root m minus n. You have the 2 to cut. Very close actually. If you could square, we'll get a and b. So let's square both sides. So what will happen? This will become a, this will become b. And squaring, numerator square, denominator squaring. So root of m plus n whole squared plus root of m minus n whole squared plus 2 times root of m plus n into m minus n. Same in the denominator, root of m plus n squared plus root of m minus n squared 2 times root of m plus n into m minus n. This we know, square and root, they will cancel each other. M plus n, here m minus n, here 2 times root of m squared minus n squared. Here it is m plus n, m minus n, 2 times root of m squared minus n squared. Now here it is 2m, so that 2 will be common throughout. You can have it cut m plus m to n, m plus m to n. 2 can be common throughout. 2 times m plus root of m squared minus n squared, then 2 times m plus root of m squared minus n squared minus. There's a minus. So what will happen? The 2 will cancel, and that's exactly what they have asked us to show. Of course, in ratio form. This is fractional form, get converted into ratio form. In the 20th problem, they say that ABC is in NAP, BCD is in GP, 1 by C, 1 by D, 1 by E is in AP. Then you have got to show that AC and E is in GP. We will see what is given. And we'll just check this. What they have asked us, if this has to be shown, you have to show that C squared equal to A. That much we know. Then from given, one things we will find out. If these all three are in GP, to B equal to A plus C, first thing, right? This is in GP means C squared is BD. This is in AP means 2 into 1 by D is 1 by C plus 1 by E. This is not so convenient. Let's solve this. 2 by d equal to e plus c by c. Let us see now what can be done here. Okay. Since we require c squared, let's consider this. Consider c squared equal to bd. We require a and d only. So b can be replaced from here, a plus c by 2. D can be replaced from here. How? Call this as d by 2 equal to c by c plus e, taking reciprocals on both sides and take the 2 on the other side. So it is 2ce by c plus e. This is 2 only, na? Yeah. So that 2, this 2 cancels. Alright. So what happens? You can have one of the c's also cancelled here. So c equal to a plus c times e, and this c plus e, let's take it here. And let's open the bracket. So what will happen? C squared plus ce is equal to ae plus ce. CE cancel. You have c squared equal to ae. That is what they've asked us to show, right, at one shot, isn't it? So hence proved that all those are in GP. In the next problem, nothing new, we have done it in the GP exercise, but that time we had got panicky that this kind of terms, where we have 5, 55 and all that, they are neither in AP nor in GP, so what we should do? So we did a bit of multiplication division and got it converted into GP, and then we used principles of GP and got the answer. That is what we'll do here also. Let's consider this term, because there is no possibility we take first 5 out. 1, 1, 1, like that we have n terms. Now, we will multiply and divide by 9 so that the value doesn't change, but it will help us achieve our purpose also. The 9 can be taken inside, so it will become 9 plus 99 plus 999 and so on. And when we look at this term, this is like 9 is 10 minus 1. And this is 100 minus 1, which is 10 squared minus 1. This is 10 cube minus 1. Like that, the last term obviously is going to be 10 raised to n minus 1. So we club terms together. 10, 10 squared, 10 cube, and last 10 raised to n. And minus 1, minus 1, minus 2. Minus 2, minus 1, minus 3. Like that, all terms when we collect, it will become minus n. Now this is remarkable. Why? Because it's a GP. It's a GP with A as 10, R as 10 and n terms, right? So sum to n terms we know, formula, Sn we know, it is A R raised to n minus 1 by R minus 1. So let's see how we can get this. This is A for us 10, R 10 raised to n minus 1 by 10 minus 1, which is 9 minus n. This is a sum for this. If you want, we can open it up, but it's okay if you keep it like this. We also have a second subpart here, which says that it is 0.6, 0.66 and so on. Same way till n terms. So this is like writing 6 by 10. 66 by 10 squared. 666 by 10 cube and so on. Take the 6 out. So 1 by 10. 1 by 10 squared, 1 by 10, no sorry, 1 by 10, 11, 1, 1, 1 and so on. It is going to be 1, 1, 1, 1, 1, 10 raised to n, that we can predict. Then like before, multiply and divide by 9 so that we can achieve our purpose. So the 9 has got inside, it will be 9 by 10, 99 by 100, 999 by 10 raised to n, and the stretch of 9's by 10 raised to n, 10 raised to 3, sorry. Yes. Now 9 by 10, very similar like this. 9 by 10 is also 1 minus 1 by 10, if we carefully see. So we are going to make that conversion. Everywhere we will apply this. This is as good as writing 1 minus 1 by 10. This is 1 minus 1 by 100. This is 1 minus 1 by 1000. Automatically last term is 1 minus 1 by 10 raised to n. All the ones we will club together. So 1 plus 1, 2, 3 like that will become n. and all the minuses outside, club the 1 by 10s together. That's it. This is a GP with A as 1 by 10 and R is 1 by 10. And therefore, what is your SN? SN formula will be A times 1 minus R raised to N by 1 minus R. So let's check what the answer will come out. Let's quickly write the answer here. The answer will come to 6 by 9 times, N is of course there, minus A for us, it's 1 by 10, 1 minus 1 by 10 raised to N, and in the denominator 1 minus 1 by 10, which is 9 by 10. So that 10 will cancel and 9 will survive. 6 by 9 times N minus 1 by 9 into 1 minus 1 by 10 raised to N, or 1 by 10 raised to N. That's also okay. Here also, if you want, you can open the bracket, you can leave it like that. So that is our problem number 21. With this, we finish this video, and with fresh problems we come in the next video. Thank you.